Hello students, here we are going to learn about network design and operation. So this topic is divided into some subtopics. So starting with the first topic, traffic models and the performance criteria. So according to the analysis of traffic provides information like the average load, the bandwidth requirement for the different applications and the numerous other details. So for that, traffic model enables network designer to make assumptions about the network being designed based on past experience and also enable predictions of performance in the future's requirement. So the traffic model are used in the two fundamental ways as a part of analytical model or to drive discrete event simulations known as a DES. So start with the first Poisson distribution model. So this is one of the most widely used and the oldest traffic model is known as a Poisson model. So the memoryless Poisson distribution is the predominant model used for analysis traffic in the tradition of the telephone network. So the Poisson distributed process or Poisson process is characterized as a renewal process. So in Poisson process, the inter arrival times are exponentially distributed with the rate of parameter of the lambda. So this is equations given over here. P of n of less than or greater equal t. So in this case, this particular the Poisson distribution is appropriate if the arrivals are from large number of independent sources and referred to as a Poisson sources, and thus distribution has mean and variance equal to the parameter of lambda. So the next model is Pareto distribution process. So the Pareto distribution process produces independent and identically distributed IID inter-arrival times. So in this case, it generally, if X is a random variable considered in the particular process with the Pareto distributions, then the probability that the X is greater than some number X is given by the particular terminology. So capital X is a random variable and the small x is considered the some number. So for that, this equations is satisfied the following condition. So in this case, where k is a positive parameter, k is a positive parameter, and consider xm over here. So xm is the minimum possible value of xi, minimum possible value of xi. So the probability distribution and the density function are represented as, I'm writing down equation over here, ft is equal to 1 minus alpha divided by t into beta. So this is equation is generated. So in this case, where alpha and beta greater than equal to 0 and the t is greater than or equal to alpha f of t. So this is equation is generated from this particular Pareto process or Pareto distributions process. So next is a Weibull distribution process. So basically the Weibull distribution is one of the most widely used lifetime distributions in reliability engineering, or it is a versatile distributions and that can take on the characteristics of various or other types of distribution based on the value of the shape parameter. So the Weibull distribution process is a heavy-tailed and can model then fixed rate of on period and on off period length. So that is useful for the particular case. And so when producing the self similar traffic by multiplexing on off sources, or at that time it will be used. So the distribution function in that case is given by the equations ft is equal to 1 minus a minus t divided by beta into alpha. So where t is greater than 0. So and the density function of the Weibull distribution given by the following equation alpha into beta minus alpha into t raised to alpha minus 1 into e minus t by beta into alpha t greater than 0. So are the scale and the location parameter respectively in the case of Weibull distribution process. So next is Markov and embedded Markov models. So the particular Markov models attempt to model the activities of the traffic source on a network by finite number of states. So the accuracy of this particular model increases linearity with the number of state used in this model. So however, the complexity of the model also increases proportionally with the increases number of the particular state. So an important aspect of the Markov model, so the Markov property states that the next or future state depends only on the current state. So in other word, I will to explain this that the probability of next state denoted by some random variable like x n plus 1, so that depends only on the current state and indicated by the xn and not on any other state like xi, so where I always less than n, I always less than n. So this is for the Markov and embedded Markov model. So next point after traffic model is a performance. So managing performance of the network involves optimizing the way of network function in effort to maximize capacity, minimize latency, and offer a high reliability regardless of the bandwidth available and the occurrence of failure. So these are the basics of performance in the particular optical network designs. So network performance management consists of like measuring, modeling, planning, designing, optimizing the network to ensure that the carrying traffic with the speed, particular the capacity, particular expected by the applications using network or required in particular scenario. So the network are different types and can be categorized based on several factors. So however, the factors they affect the performance of the different network are more less than the same. So this involves the parameter like latency, packet loss, or the throughput. Throughput is a performance parameter. So in order to design a high performance network, for any type of network, detailed analysis of the above factor is a crucial law or the crucial steps for designing the network. So often that foremost step in such kind of analysis is to study the different traffic on the network using the previous all the models or any kind of consequences that the traffic model used to understand the flow of traffic in the network and how they model using the real-time characteristics on the network become a vital parameter, and choosing a model that does not describe the real-time characteristics on the traffic and the particular network, so and it also provides some kind of features also. So next is a network type. So there are basically two types, static and the reconfigurable or redesignable. So the layout of link and the switch boxes that establish interconnections between them. So the link are essentially physical wire or in terms of channels. The switch box are device like that the connect the set of input to the set of output links particular available in these boxes or the switches. So there are two group of network topology are static and the reconfigure. So I'm just explain about the some detail in the both the static and the reconfigurable. So static network provide fixed connections between a node with the static network. So link between the node are unchangeable and cannot be easily reconfigured. Or in the case of the second reconfigure networks, they provide reconfigurable connections between node. The switch box is the basic component of the dynamic network. With this network, connections between node are established by setting of the set of interconnected switch boxes. So first, switch networks, static networks. So in this case, there are various type of static networks, all of which are categorized by their node degree. Our node degree is the number of link or number of edges connected to the particular node in the network. Some well-known static network considered as a measurement unit called as a diameter can be used to compare relative performance characteristics on different network. So the diameter of network is defined as the largest minimum distance between any pair of node. So the minimum distance between a pair of node is the minimum number of communication link or number of hop. Suppose I am connected one devices to the next devices. Between there are two intermediate node is there. So particularly three communication link or three hop number is required to reach that particular the node. So this is a hop. So that data from one of the node must transfer in order to reach their other node. So in the case of shared bus, so also known as a common bus in the structure. So it is the simplest type of static network. The bus is the highest degree of one and is an architecture that all node share a common communication link for that purpose. Second is a linear array. So linear array is a combination of degree 2 has each node connected with the two neighbors node. So the linear quality of this structure comes from fact that the first and last node are also not connected. And the third case considered as a ring. So in this case, another networking configurations with a simple design kind of ring structure. So it is a similar to like a linear array. So each node is connected to its two of neighboring, single node to two of neighborings, and case the first and last node are also connected from the ring compared to the linear array. So in the next case, reconfigurable networks. So they provide reconfigurable connections between the nodes. Say they can change the connection in these particular switch boxes. So the topology of dynamic network, sometimes it is known as a dynamic network. So in this case, the physical structure of this network is determined by the switch boxes and the interconnecting link. So according to this switch box, the basic component of the network, the cost of the network, according to the hardware, how many number of hardware used in the particular network is measured at the number of switch boxes is required. So therefore, the topology of the network is the prime determinant of the cost. So to clarify the preceding terminology, so let us consider the design of dynamic or reconfigurable using a simple switch box. So there are two kind of boxes I have to consider in this example. One is a straight and the second is a exchange. Clear? So then particular straight line, I'm considering the x and y. So in the both case, x and y is the same. Yeah. So in the case of a straight, consider as a straight line. So here we consider as a s is equal to 0, and here we is consider s is equal to 1. Clear? So in the simple switch, the two important input x and y has a two output z0 and Z1. So a control line, so this is a control line known as a S, so determines whether the input line should be connected to output. So one connection is available. Clear? So in this straight state, connection is there. So in the case of straight, so for this example, the S is equal to 0. So the input are connected to output in the straight line or straight state. So X is connected to the Z0 and Y is connected to Z1. So when the control line consider as a S1, so the input are connected to output in the exchange set. So in this case, the X is passing through Z1 and Y is passing through Z0. Clear? So the crossbar switch can be used for connecting a set of input nodes to the set of output nodes. So the crossbar switch provide all possible permutations as well as support for the high system performance of the particular network design.